Okay, so we're looking at physical properties of alcohols. So we have here a molecule of ethanol and a molecule of water. So what are they doing? They are forming hydrogen bonds between them. Okay, so one of the main features of alcohols, one of the main properties, characteristics, is that they can form hydrogen bonds. And remember, one of the conditions where we have to form hydrogen bonds is a molecule has to have an OH bond, covalent bond, an FH, that's fluorine hydrogen covalent bond, or a nitrogen hydrogen covalent bond, one of those three. So we have here an oxygen hydrogen covalent bond, which is an essential condition for a molecule to be able to form hydrogen bonds. What we can see here is a molecule of ethanol forming a hydrogen bond with a molecule of water. Okay, so if you look at this part of the ethanol molecule, is just like water in a way. All you have done is you have replaced a hydrogen atom with an ethyl group. Okay, so when you draw this hydrogen bond, this diagram for a hydrogen bond, you can adapt the one that we did before between two water molecules and just replace a hydrogen with an ethyl group or a methyl group, any alcohol you're going to draw, and the hydrogen bond is drawn the same. So remember that this is really important. This here, the dotted line, is the hydrogen bond. It has to be formed between hydrogen in one molecule and the oxygen in a different molecule, because remember, it's an intermolecular force. Okay, and very importantly as well, this hydrogen bond has to point towards the lone pair of electrons in the oxygen atom. Okay, so this is the hydrogen bond here, so you better label it to make it absolutely clear. So this is your hydrogen bond. And other important features that you have to have when you have a hydrogen bond is you have to show your dipoles. Okay, so here in this water molecule, you have to put your delta plus on the hydrogen and your delta minus somewhere near the oxygen, and you do the same for your ethanol molecule here. So we have a delta plus here in this hydrogen and a delta minus here near the oxygen. And the implication then, what happens because alcohols form hydrogen bonds is, as we've seen, they can form hydrogen bonds with water molecules, and therefore they dissolve in water. So this is the first physical property of alcohols we're looking at. They dissolve in water. Like, for instance, you have examples in daily life, wine or beer. Okay, so wine and beer are mainly water. Okay, so they have some alcohol, obviously some ethanol, otherwise people wouldn't drink them. Okay, but it is only about, 5 to 12%, okay, ethanol, and the rest is mostly water. It's also important to consider that only short chain alcohols dissolve in water. Okay, so we have methanol dissolves in water, ethanol dissolves in water, propan 1-ol, propan 2-ol also dissolve in water. But the moment you have about 8 carbons in the chain, then you have a too big non-polar part of the molecule, in which case it won't dissolve. Okay, so for instance, octanol, like octan 1-ol, octan 2-ol, they barely dissolve in water, and above that, 10 carbons or more, they don't. Okay, because then the non-polar part of the molecule is too big, and it cannot actually come between the hydrogen bonds formed by water, and that is the problem. Okay, that water molecules form hydrogen bonds between themselves. So to dissolve anything in water, you have to break some of those bonds, and that's why then when you have a molecule that is non-polar, it doesn't dissolve in water. And the same way you can have a molecule with an OH but with a very long non-polar chain, and that doesn't dissolve either.